Assalamualaikum and hello everyone. My name is Fizan bin Muhammad Nizam. My number matrix is B08221462. So for today, I want to present about assignment 2, subject BEET3403, Digital Communication. So firstly, what is OFDM? OFDM is Orthogonal Frequency Division Multiplexing, a digital modulation technique used in telecommunication to transmit data over radio wave or optical fibers. So for the next part, how OFDM works. Firstly, subcarrier splitting breaks the data into many narrowband subcarriers. Second, orthogonality, these subcarriers don't interfere with each other. Third, guard interval adds a buffer to deal with signal echoes. Fourth, IFFT, inverse fast Fourier transform, combines subcarriers into a signal. 5. Transmission, send the signal over the channel. And 6. FFT, fast Fourier transform at the receiver, separates the signal back into subcarriers. And lastly, demolition, extract data from its subcarriers. For this part, what the advantage of OFDM? So firstly, efficient spectrum utilization by dividing the spectrum into narrow subcarrier or FDM can transmit data at high rates while mitigate the effect of frequency selective fading. So the second, robustness to multipath interference. The guard interval in OFDM helps in dealing with multipath propagation, making it suitable for use in environments with severe channel condition. And lastly, flexibility. OFDM can adaptively allocate subcarriers based on channel conditions, providing robustness against varying channels conditions. Hello everyone, welcome back with me. So for the last part, we're gonna show about what is OFDM, how it works, and the advantage of OFDM. So for this part, we're gonna do this assignment through MATLAB or Simulink. So let's go. So for the instruction part, each individual need to make simple report and present it online. This is the question. Figure 1, incomplete MATLAB QPSK-OFDM system Simulink to be complete. So we need to complete this QPSK-OFDM system. And then figure 2, QPSK-OFDM system output. So we should get this output if we do the incomplete QPSK-OFDM system. Then first task, we need to construct an QPSK-OFDM system in MATLAB as shown in figure 1 and obtain the result in figure 2 based on the specification below. So this is specification that we need to follow. So task 2, modify the circuit with AWGN channel instead of using the random source generator to evaluate the result on different value of SNR. So we need to change random source to AWGN. Then we through the MATLAB. So firstly, we need to run this coding. So this is our coding. We should get M equal to 4 and balance equal to 100 and stimulus equal to 1 minus 6. For the next part, go through the first task. So this is the first task. So for the first task, we use random source. We need to check the random source through the specification that we need to follow, like sample times and n balance. Then if we done the specification is right, we need to run and should get the output that we need, like this. If you go through, the output is the same like we do. So I got the output and I paste it in the result. So this is my output. So for the next part, I changed the random source to AWGN. So this is the AWGN. So in the AWGN, we need to do mode. We change to SNR, and then the SNR, the instruction is SNR is different value, means different to what? to change the SNR and check the output. So we apply right now is 30 dB SNR. So this is the output that should we get. Then the output same as in the result and discussion. So this is result that I get. So 30 dB. So what happen with if we change to 1 or 10 dB? So right now we need to stop the system and we to change the value of SNR like 10. We apply that, then we try to run. So you can see here the result is different. The result is different like this. This is 10 dB, this is 30 dB. In the discussion, I talked about task 1. Between the FFT and IFFT stage, we add conversion from complex to magnitude and magnitude to complex with a random source as seen in the block diagram above. The constellation diagram then shows that there is some residual noise in the center and that the SNR noise is widely distributed. Notably, after the FFT, the noise was totally removed. So for the task 2, this is my opinion. We switch from using a random source to another AWGN to generate the SNR value in the later portion of the assignment. We notice that the noise is scattered at 1 dB SNR. We observe that the noise in the center does not break up as the SNR rises to 30 dB. The noise distribution becomes noticeably important at 10 dB. QPSK is the processing of modulating carrier signal phase to represent digital data. QPSK modifies both the amplitude and the phase of carrier signal, in contrast more straightforward modulation method like amplitude shift keying ASK or FSK, which merely alter the carrier signal amplitude or frequency with 4 potential phase shift 0, 90, 180 and 270 degrees, corresponding to the 4 possible combination of 2 bits 0, 01, 10 and 11. Each symbol in QPSK represents 2 bits of digital data. When compared to more straightforward modulation algorithm, this enables a higher data transfer rate. So, orthogonal frequency division multiplexing of OFDM is modulation technology that allows data to send simultaneously over several subcarriers. These subcarriers don't interact with one another because they are orthogonal to one another and have tight frequency spacing or FDM, provide resistance against frequency selective fading and intersymbol interference, as well as efficient data transmission with high spectral efficiency by splitting the available frequency spectrum into multiple orthogonal subcarriers. Modern wireless communication protocols including Wi-Fi, LTE and DVB/T heavily rely on OFDM. So for the conclusion, by including MATLAB simulation in the teaching of OFDM multiplexing, student comprehension is improved through practical application, visualization and hands-on experimentation. This method encourages kids to think critically and solve problems, and it gets them ready for the future profession in associated fields. So that's all from me. Thank you.